Hello everyone, myself Mrs. Aparna More would like to discuss with you some important points regarding Multisim software. So today we will be seeing a Multisim software using NI Multisim 13. So whatever you see here, this is a Multisim window. In this Multisim, you can use this Multisim software for building a circuit, for simulating and testing it. This Multisim is useful in analog, in digital, as well as in power electronic subjects. Today we will discuss some circuits in Multisim which are used in basically the subject called as electronic device and circuits. It's a second year subject for electronics and telecommunication department in the SPPU University. Firstly, I'd like to introduce you to NI Multisim. You open the Multisim and you get this screen. There are this design tools box. Now you can have n number of designs. So this is design 1, this is design 2. I've opened a new screen for you. These are the tabs. Then these are the instruments, the multimeter, the function generator, the wattmeter, oscilloscope, 4-channel oscilloscope. So these are all the instruments which we'll be using. Then we have, first of all, we'll directly start. So before starting, what we will do is we'll title our circuit. So for that, go for place. In text, type here DC analysis for CS amplifier. So this is the topic, this is the title of our design. I'll type it in Times New Roman. Looks good. And we'll increase the font. So this is the title. The next we want to do is we want to build the circuit. So for that we will need a JFET, that is the transistor, junction field effect transistor. So go to place. There is this option called as component. In the component there are many groups. The groups such as source, which has all the power sources, the ground. Then there is basics, that is all the components, resistor, capacitor, inductor, electrolytic capacitor, and so on. Then you have diode family, then you have transistors which have BJTs, N channel, P channel, then you have MOSFET, enhancement mode, depletion mode, then you have a JFET, N channel, P channel, then you have CMOS, then you have TTL circuits. So all these, whichever you need, you can have it from here. So first of all, we'll go for a JFET, N channel JFET. In that N channel JFET, you have many options. So these are all the various options you have. We will select BFW10. Say OK. Place it here. So this is our JFET. Then again we need some resistors. So we will build a basic self-bias CS amplifier. Okay. So basic self-bias circuit. So I would like to have a resistor. So there is this option. There is a shortcut here. Resistor. In that I'll directly type the value which I want. So I need a resistor having the value of, say, RD value is 3.9K. So 3.9K is the value which I would prefer. Say OK, place it here. Then we want it vertically. This is horizontal, I want it vertical. So right click on this. There is an option called as rotate 90 degree clockwise. So rotate it and place it at the position which you want. Then resistor, again I want a resistor of 1 mega ohm, that is RG. Then another resistor I want of the value 220 ohm, that is RS. So I'll have all these. Then we'll place it vertically by again right click it. There is an option called rotate 90 degree clockwise, and you have it as you want. Then we'll make the connections. So these are the basic elements which we are having, the basic components for a circuit. Now we need VDD. So here there is an option called place source. In the source there is an option called VDD. Say OK and place it here. Then we as well need a ground. So a ground is taken from the source and placed. Connect that ground as well as connect the VDD. Now the value of VDD which we want is of 20 volt. So what I did was I double click on that value. There is an option called as voltage. So in that I'll type 20, say OK. Now we want to find out the voltages of a self-biased circuit. Just take this above, and we want to find out the voltage using a multisim. So I'll click on this multisim and place it here. We want to find out the voltage between the drain terminal and the source terminal. Now this is a basic self-biased circuit. The terminals of the JFET are, this is the drain terminal, so this is the gate terminal, and this is the source terminal. If you want to label them, what we can do is, we'll right click on this wire, properties, there is option called as preferred net name. Now instead of 4, I write here drain. Okay. Then instead of 1, I'll write here gate. And instead of the source, we'll write, instead of 3, we'll write source. So the drain terminal, the gate terminal, and the source terminal. For the beginners, it's very important to know the terminals. Then we need to find out the voltage between the drain and the source, or the voltage between the gate and the source. So for this, what we want to do is, we'll connect the positive of the voltmeter to the drain and the negative of the terminal to the source. Then run it and double click on this. So this is 6.915 volt, which is the value for VDS. Similarly, we can find it for, okay, we cannot change anything if the run option is going on. So I first of all stop it, then delete this. Then I connect the positive of the voltmeter to the gate and the negative to the source. Run this, double click on it. You are getting the value as minus 698.25 265 millivolt. Now, I'll show you one more option. What you can do is stop this. We will find out VDQ, that is the voltage between the drain and the ground. So run this, that is VDQ is 7.614 volts. Then VGQ, that is the voltage between the gate and the ground, that is 8.24 microvolts. And VSQ, that is the voltage between the source and the ground. So run it, double click, you will get this value. So if you want to find out the value of VDS and you have the values of VDQ, VSQ and VGQ, then VDSQ or VDS value will be VD minus VS and VGSQ will be VG minus VS. So we can have that. So these are the voltages which we are expected to find out. Then we want to find out the current between the drain or the current flowing through this path. So I stop this and the current is flowing through the path. So what we will do is we'll remove this connection here and we'll make the connection. Okay, so this I keep it like this. So this is the current meter which is connected through this path. Run, double click, and option is ampere mode. We want to find out the current, so it should be in amperes. So it's 3.175 milliamps. So this is the value of IDQ. This is how we find out the voltage and the current for a self-biased circuit using DC analysis. DC analysis means you only connect VDD, you don't give any AC signal for that. So stop this. Now this another option which I will like to share with you. So again I'll right click on this and properties, I'll give the name as drain. Okay. If you want to see all the values at a glance, so what you need to do is in the option known as simulate, analysis, DC operating point. Now you have all these options like drain, gate, source, VDD. Now what we want to do is we want to find out the voltage of the drain, that is VDQ. Click on this, click on the add. So your V drain goes here, then V gate, add, V source, add. Now what we want is we want the current flowing through this R1. So what we'll do is I R1, I'll remove this which we don't want. Then we want all these values, that is the current flowing through R1, the voltage of the drain terminal, the voltage of the gate terminal and the voltage of the source terminal. This is the value which we are expected to find out. Say simulate. Now, so this is the voltage of the drain terminal which we had got, that is 7.61415 volts. That is the voltage of the drain terminal. Then VG, that is voltage of the gate terminal, is 8.3 microvolts. And voltage of the source terminal, that is VS, is 698.68 millivolts. Then current flowing through R1 is 3.17 milliamps. So these all values we can see at a glance. So this is how it appears. Okay. So this is the circuit and this is the result. So this is the DC analysis of self-biased circuit or a CS amplifier. I hope this video will be helpful for you. Thank you very much.